So here's a typical spectrogram in REW, and we'd be using this to see how the decay time, the reverb time, how our acoustic treatment is controlling that, making it shorter. In this example, we look across here, and for most of the frequency range, all the energy is gone by 200 milliseconds, but as is typically the case in the bass area, we have room modes making things ring out, and the longest one here is around 46 hertz, and it's 450 and a smidge milliseconds. Except this information is not true. Let me make some changes. This is what's really happening. This is the same file, and the decay time for most of the frequency range is not 200, it's 65, pick a number, 70, it's almost a third of the number it was implying before, and at the base frequencies, the maximum is in the 250 millisecond range, not 450 milliseconds. So, what's going on? What's going on? REW presents us with a multiplicity of different views, different angles to analyze our audio. Perhaps the single most informative one is the spectrogram. Other software might call it a spectrograph or a sonogram or a sonograph. It's all the same thing. Names for a display showing frequency against time. Now there is a key parameter that the user can control in a spectrographic display that controls the trade-off between time resolution, time accuracy, and frequency resolution. If you are aware of that, you can use that to make sure that whatever aspect is of primary importance to you at any moment, you get the information you need. If you're not aware of it, you could easily be taking measurements which are actually false. And that's bad. So this is the Audacity program, a well-known free audio editor and a file. Let's zoom right into one, and we want to measure the duration of this event. The answer is coming down on this lower part here, currently at 72. It depends how far we pull this thing into the, but it's in the ballpark of 100 milliseconds. Let's switch over to a spectrographic view. Now, I'm working in black and white. The black is the high energy, the sound, the white is the silence. So we see the instantaneous event, the hand clap, goes across all frequencies once, and then we have the reverb or the decay in the room on this tail here. Where it gets interesting is where if we take the spectrogram settings, now we're on a parameter they call window size, 512. What happens if we go right up near the top? It looks like we've wiped a wet rag over the top of it and smeared it. So the thing is, if we accepted this, when we came to measure it, its duration, we get a number that's twice as long as we know is actually accurate from going back to the waveform. This is Adobe Audition. We open the same file. We do the same thing. We look to measure the duration. Our measurement comes out right down here in this top box there. And we see it. So, what are you going to say? 90 milliseconds. Then let's transfer to the spectrographic view. So what we have here is a spectrogram with a very high number in the resolution. Just like we saw in Audacity, a very high number. It's now termed different. It's called resolution instead of window size. But if we drop this down, so these lower values portray time more accurately. There's our hand clap. Exactly the same information. But if you have inappropriate choices in a spectrographic display, you can distort time considerably. Let's think about what happens to an individual WAV file as it's converted into a spectrographic view. The WAV file represented by the green rectangle, let's say it's a 48K sampled file. It's converted or processed into the spectrogram in small steps, repetitiously actioned throughout the file. And it's the size of this white rectangle, it's the number of samples per byte that determines whether it has better time resolution or frequency resolution. I'll let you read the text here and then show you some graphics, which I hope will get the point across and empower you to get the results you want from the REW spectrogram. So you can see there what a enormous difference changing that parameter makes. Right, well, that's all I got to say. Thanks for watching through the video, and hope it will be of use, interest to someone out there. I'll see you in the next one.